Hey Number Crunchers, it's good to be back with you. This is another in a series of videos about mathematics, and today I'd like to talk to you about how to divide complex numbers. Now, a complex number is just a number that has a real and an imaginary part, and they look like this. Usually designated by the letter Z, not sure why, I think it's probably just tradition. And it has a real part and an imaginary part. So 3 plus 4i is an example of a complex number. I think you know, but in case you don't, that's the real part, and that's the imaginary part. Oops. Now, this can't be simplified any further than this. There's no way to break this down into anything more fundamental. There's two kinds of numbers in life. There are real numbers and there are imaginary numbers. That's it. I checked with some very capable mathematicians on campus just to see if there was anything else out there lurking that we might be worried about, and there is not. In the sense that we think of numbers anyway, there are real numbers and there are imaginary numbers. Now, to be clear, those worst names ever. There is no name in mathematics anywhere worse than real and imaginary. The problem is it makes real and imaginary makes it sound like this is somehow mathematically legitimate and this isn't. Well, that's not true. These are just the two kinds of numbers that exist. Now, historically, people tended to throw this away because they weren't sure what to do with it. Just to remind you, I is a square root of minus 1. Well, you can't have a square root of minus 1 and have the result be real. Well, it's imaginary. And so in the old days of mathematics, people would just throw that away as, well, I don't know what it is, it must not mean anything, I'll just pitch it. Well, the problem was when they retained this, they kept getting the right answer. Well, now there's a field called complex analysis, and it's built on a very firm foundation of proof. There is absolutely no question these are both mathematically legitimate. They're just the two kinds of numbers. Now, we don't use complex numbers in our day-to-day life a lot. If you find yourself balancing your checkbook with imaginary numbers, something's probably wrong. But in the science and engineering world, whole swaths of mathematics and engineering and science are impossible without complex numbers. Electrical engineering hardly exists without complex numbers. How do you do electromagnetism or AC signals, oscillating signals, without complex numbers? I don't know how to do it, and I don't think anybody else does either, at least not in any practical sense. If you work in vibrations, if you work in acoustics, there's complex numbers everywhere. So the world around us depends on these. So that's the bottom line. That's the big picture. So because this is just another type of number, all the basic mathematical operations have to be defined. Addition, multiplication, subtraction, division, all four of those have to be defined. Well, the only one that's really very hard, or very maybe counterintuitive, is dividing complex numbers. Let's start by multiplying, and then let's move over to dividing. Let's say I want to multiply two numbers. I want to multiply 1 plus 2i, and then multiply it by 3 minus I. Well, what you can do here is treat this similar to the way you'd treat a polynomial, just expand it and multiply. So let's do this. 3 minus I times the first term plus 2i times 3 minus I. Now remember, if I is the square root of minus 1, then I squared has to equal minus 1. That makes things a little simpler. So let's remember that. So this is going to be 3 minus I plus 6i minus 2i squared. All right, so that's an imaginary number, that's an imaginary number, that's real, and that's going to be real. So let's do the real terms first. 3 plus 2 times, or minus 2 times minus 1, plus 6 minus 1i, and you get 5 plus 5i. Now, could you look at that and tell that's going to be 5 plus 5i? I don't know. Maybe if you do it enough times, you develop some intuition. I don't have it. I have to go through this. I can't just look at that and tell you what it's going to be. And division is even less intuitive. Fortunately, it's not very hard. All right, so let's stop there, and now let's go over to division, okay? Now, instead of multiplying these two numbers, let's divide them. Okay, and I've got my cheat sheet over here just to make sure I do this right and make fewer mistakes when I do it that way. Now, one thing, there's one operation called that we're going to use, and it uses an entity called a complex conjugate. And all complex conjugate means is we reverse the sign on the imaginary part. So if z equals 3 minus I, and complex conjugate gets identified using some different terminology in different books. I'm just going to use the star up there to indicate conjugate. That's 3 plus I, and that thing right there is an entity called a complex conjugate. Now, when mathematicians see something enough times, they give it a name. Now, it's not always a very helpful name, and maybe this is one of those. But complex conjugates have an interesting property. So let's multiply this number by its complex conjugate. So 3 minus I times 3 plus I. All right, so that's going to be 3 times 3 plus I minus I times 3 plus I. Okay, all I did was expand this out. So I'm going to get 6 plus 3I minus 3I minus I squared. Well, it looks to me like that's going to be, and that are going to cancel out. Minus I squared is 1, because I squared is minus 1. That sure looks to me like that's going to be, that's not 6, that's 9. Sorry, guys. That's going to be 10. That's a real number. Does that work for all complex numbers? Sure it does. Let's try this. Instead of using numbers, let's use letters. A plus bi times a minus bi. Now to speed things up, I'm going to use FOIL. First, outside, inside, last, just like you would use for a polynomial. And I get a squared plus abi minus abi minus b squared I squared. And I get a squared plus b squared. So I start with just any complex number, multiply it by its complex conjugate, and I get a real number. Doesn't matter what a and b are. This is a specific case. This is the general case. So why am I telling you this? Well, here. If I multiply this by 3 plus I over 3 plus I, wait a minute, can I do that? You can't just arbitrarily multiply something, can you? You can if it's 1, because you don't change the answer, and 3 plus I over 3 plus I is indeed 1. Okay, well we already know that's 10, so this is going to be 1 plus 2I times 3 plus I over 10. Okay, and maybe we'll assign the result to z just to have an equal sign there. All you got to do now, we already know how to multiply. Well, this is easy. Let's try this. So 1, here I'm going to use FOIL again just to speed things up. So 3 plus I plus 6I plus 2I squared over 10. Alrighty, looks to me like that's going to be 2 times minus 1, so that's 1 plus 7I over 10. And if you plug this right there into your programmable calculator, MATLAB, MathCAD, whatever, it comes out as 0.1 plus 0.7I. Well, that's this. So there you go. That's how to divide complex numbers. Now, the way I've done it here is using what's called a rectangular form. There's also a way to do it in polar form. If you'd like to see it in polar form, leave me a message in the comments section of this video, and I'll be happy to shoot that video as well. Hope this helps. We'll talk to you next time.